two different segmentation algorithm has been used. One is improved dynamic programming technique. The second is active contour segmentation technique. What's that improved dynamic programming technique? Determination of the cost function of each point in the polylines of identified region. What the determination? Go to that picture. Yes, see that one. This is an entire part of an image. Yes. So as per that improved dynamic, both the median and plus sign shaped filter has been used from that left to one right. Yes. So in this, what that polylines, you think about that one. These are all like lines starting from the pixel up to this end. N number of polylines are there. Okay. So in your longitudinal image, so for example, this is your lumen. It might be of intima, likewise. So adventitia and other tissues. Okay, you are interested in this portions. Okay, so for example, there are around some 10 lines are there. Okay, they called it as polylines. Had to process that process from this first pixel, and there are approximately some 200 pixels are available in this one. Think about it. Okay, some continuous pixels are formed in likewise that n number of lines. Okay, go to that slide. Next. So determination of the cost function for each point in the polyline. For each pixel in this line, so each pixel in the lines you have to measure a cost function. Where you come across the term cost function in signal processing? Cost function. The same things is available, nothing new in this algorithm. Where? Not an advanced boundary detection and all. In simple filtering concepts in your adaptive filter, wherever you will need to determine that error to be of minimal, mean squared error, there you are using tap weight coefficient values. Okay, there you come across that overall component mean content of that filter coefficient value as J as in cost function. This you might have come across in DSP. J. Based upon that J cost function alone, you are going to decide about your filter components in that one. Clear? The same concept has been used, but that methodology gets differ here. That's the only difference. Okay. Then estimation of the boundaries by optimizing the cost function. So you are going to determine the cost function for each and every pixels which are present in that polylines of that one up to your image end. You are going to proceed. Then measurement of the distance between the intimal and median layers of the firewall have been identified, and evaluation has been done for not only for a single patient, for other patients also. Next. This is the cost function. So you know that when polylines with n vertices are represented as this one, P1, P2, P3 up to Pn for each and every line, where Pi minus 1 and our horizontal neighbors, n represents that horizontal length of a contour line. That cost function, which is defined as a sum of local cost along with this line, has been used to determine a polyline to be an exact boundary line. This is your cost function. Okay, summation of averaging of all the cost function values in that polylines is present in that one. How that C of Pi is measured? The minimization of the cost function is used to determine that optimal polyline. What do you mean by that optimization technique? Whenever you want to take some decisions, you will need of optimality principle. Why? The maximum options which you are going to give to obtain your very minimal error near to and zero. That's an ultimate idea of any algorithm or any product or any component which you are going to work together. Clear? So here your ultimate idea is to get that cast function to be of very minimal in order to determine optimal polyline. Out of this bundle of this line, you have to locate where's an intima, where's an media, where's an adventitia. For that you will need of this cast function. Then this local cast. So for each and every pixel you are going to determine this cast function. How they are going to determine that? Next. See here. The cast function is defined as W1 C discount, that is discontinuity in your pixels from the first pixel to the next pixel, then intensity average brightness of the tested pixel below to it, then gradient value. See this one, C discount is the value of polyline's discontinuity. It's going to measure that smoothness, because your ultimate idea is to determine that edge layer of that one. Okay, you have to check whether that pixel is in a continuous mode or in a discontinuity in that one, whether the delineation is proper or not. Okay, then not only this, then you have to determine this average brightness below this tested pixel. What's that average brightness below the tested pixel? I'll tell that one. Then C grade is the value of that intensity gradient where the rate of change of intensity has been done. Okay, I'll show us a sample with this. For example, how C int is measured as averaging means what? Okay, you consider that image, what that pixel values which are present in that one. Okay, now you are going to determine that C int for it. Some values are here there. Likewise, okay, that image size is what? To be of too vast. I'll consider a portions in that one. Okay, you can replace what the pixel values which is really present in that one. How you are going to determine that intensity? Because you want to start to work with this pixel, you have to work for each and every pixel value which are present in that one. Okay, suppose for this line, if you want to determine that C intent, okay, so next to that initial pixel, you have to do this process, that is 1 into 6 plus 1 into 5 plus 1 into 4 plus 1 into 2. How much? 6 plus 5 plus 4 plus 17. Okay, the C int for this below pixel value, you can replace that coded value as rest remain the same. Likewise, you have to measure the C intent from the left end of this polylines to the right end for each and every horizontal lines. Could you able to understand? Then you have to determine that C grade is the value of that intensity gradient. You consider that same sort of information. Below to this one, what's the value here? So you see that one, this value is 3. Is there any intensity variation here? Yes or no? Yes, sudden variations are there. Here, variations are there. Variations are there. You have to measure C grade as, you can use this filter. What do you observe from it? Wherever there is an variations in your transition. Okay, you can product with this one. What happens? 1 into 6 plus 0 into 5 minus 1 into 4. How much? 6 plus 0 minus 4 is Clear? So C grade for this intensity variations has been value 2. Okay. Huh? ROI aim profile that is as per our naked eye lumen looking as complete dark. Okay, you can fix a band up to 0 to 100 or 0 to 50. For each and every pixel you have to measure aim profile for it. Okay, the next higher intensity is your intima. Next higher to that intima is media. Next higher is adventitia. Go to that graph. Is intensity profile value. So you can give your system to identify the lumen portion is somewhere around 0 to 80. You can keep a code in that way. Okay. The next that is brightness is obtained at a value of somewhat 10. This is for 1 pixel which we were measured. Likewise, you have to take group of pixels, sample it, average it, then you have to come for conclusion. Okay. Adventitia near to your 200. So you can keep that one. More than 182, less than 255 is your adventitia. Okay. Likewise, you have to proceed. Next, C discontinuity is the value of polylines discontinuity in that one. Okay. So as per that picture, it's very clear that one. If this is a lumen band, it's a low intensity. So next thing is this is your intima part. This might be of media. This might be of your you are keeping that values. You have to store in your system a separate intensity value and gradient values in that one. You are replacing that values with that final database image in that one. Clear? You can give that 255 by 255 image sample values in that one. Whatever the measured values from that left hand to lower upper vertex, you have to proceed from that starting to that end. Okay, after keeping your values, how you are going to tell that one this is an intimal value, this is a lumen, or further values in that one. Okay, you have to scan that information after pouring the top values from everything. From the backwards to and forward, you have to scan the details. Okay, after you are keeping that values in this final outcome of your image. Okay. After you are keeping that one, naturally you can get an information here as, for example, some sample value for a single information I am showing here. Okay, likewise here some values. After you have stored all such a things, okay, you have to scan that information from this right to your left hand. Okay, there from that starting to this vertical and that horizontal from lower to one this end, you have to keep identify that one. Okay, you have to insist your pointer to and locate from this lower to that upper vertical where there is an maximum pixel value next to one very least minimal value. You have to keep your pointer, okay, for this particular row. Okay, and you have to locate an intensity level. Where there is an intensity level, next level to one minimum level, you locate it. Okay. Then you have to find where there is a minimal level, locate that one. Okay. After this, from lower to an upper, again you have to press in vertical to that next row, next column. Likewise, you have to keep proceed in that way. You can get an information in this way. Okay, so it clearly tells that one, this layer might be lumen and this layer somewhat the values. Okay, வேற கலர் இல்லையா? இல்லை ரெண்டுமே ப்ளூவாக தான் இருக்கு. So after you are locating that one, இல்லை ரெட்டு கொடுங்க போ, give that red. So after you find out all those C grade and C intent, if you keep loading in your output 255 by 250 in that one, you get that information in this way. Okay, you can locate where there is an maximum, immediate low value, and where there is an complete low intensity values. Okay, likewise for this vertical, this vertical, this vertical, you see that one. Clear? You can get this discontinuity C grade for this entire thing. Okay, you have to add everything. If you add, what happens? This plus this plus this, you can get your layer. So this values below to this one is other tissue values. Okay, the value in between is, it might be of your IMT. Clear? You have to backward scan from this extreme end up to this one. This is a way of determining this C cos function for each and every pixel value for a single JPEG image. It has to be done for single patient for n number of frames. Then you can generalize it. Clear? To get an cos function to be of minimum, so the weight factors W1, W, you have to choose that. What's that weight? There in signal processing for filter coefficients, you use some scaling factors to adjust. Okay, doesn't mean that one adjusting there, making your error to one near to zero there. Okay, so here by approximation, keeping that overall weight component as 1 and 2 of the weight factors are used in steps of 0.09. You have to keep add in that one. Okay, after finding out this one, you have to keep this any two weight vectors as incremental range of that one. Okay, then the weights 0.5 and 0.2 has been used in this technique. It's by means of iteration alone you can perform. It might be of differ value for your own work or your own image or your own system where you are working in that one. Okay, likewise that cos function is performed. Okay, this is summation for all the pixels which you have to measure in that entire polylines. Okay, this is one algorithm.